So I head the engineering services group in India. It's part of the global engineering and consulting services group at Siemens. And we are the customer-facing arm of Siemens. So we work with customers to solve their problems and also to make sure that they can have a solution that fits their needs. Typically, customers come to us because they have either lack of time or infrastructure to do the projects that they want to, or lack of knowledge in a specific domain or experience in that domain, or they need a cross-attribute performance solution where we can balance different streams together. So we typically work with customers both with software and expertise to give them the solution that they're looking for. And I think the next slide shows, I'm skipping slides for some reason. It's skipping one slide at a time. But the next slide here shows typically the kind of domains we work with. So we have engagements across the automotive, and the aerospace, the agriculture, and the industrial machinery divisions. And the message is the same, that we work with customers to make sure that they have efficiency and expert solutions for their products.
So Norway is actually in a good shape when it comes to mobility, but we all need to develop. So we are at the moment reshaping the Norwegian mobility sector in different ways. We have realized that that we have to develop our sector further, and all our projects within AI and artificial intelligence, and also in automated travel and mobility as a service, has had this flaw in it. We need the traveler and the society and the industry to actually be successful at the same time. So far, we have kept the traveler happy in our mobility as a service kind of pilots, and the society has also experienced a lower emission and lower congestions. But the industry has kind of not been profitable in the same period of time. So we started looking at that in last year, and we kind of discovered that we have barriers and enablers. We know that data, business model, attitudes of the person who travels, and also political resolve and all the regulations needs to be lowered as barriers. And then we have to look for the enablers like AI, autonomy, automatization, and also roaming of mass services, and also look at incentives and subsidies. So at the moment we are running projects in all those areas to try to lower the barriers of kind of enabling all the three entities to be successful at the same time. We feel that we have a really good platform to do that. We are quite used to integrate different modes of mobility already. We are listed third in the world on autonomy on the land infrastructure, and we also have a nationwide kind of data and ticketing clearinghouse already in place. So we have tools, and we have the research programs up and running at the moment. So I hope that we will be in a good shape in the future. So thank you.
Professor Seung-Woo from Seoul National University, and I'm going to moderate this session for the next 30 or 40 minutes. And this session is AI for mobility, and we have one keynote speaker, Christopher Luth from Germany, and we have Ajinkya Bhave from Siemens software, enterprise software from India. And we have Trond Hovland, CEO of Norway, ITS from Norway. So we have three excellent speakers and panelists from the globe. And I believe we should have a very interesting discussion from different aspects. Let me start asking some general questions to three of you, and you may give us some ideas or some insight about innovations in the mobility and the smart city sector in your countries where you are currently living or you are currently residing. Please tell us if you have any specific effort for deploying smart cities or smart mobility system in your countries. Why don't we start from Professor Christopher Luth from Germany. Could you?
And there are a number of trial runs of, for example, autonomous cars in Germany in specific areas. Also in public traffic, there are specific sections of the public highway system, the Autobahn, on which you might find autonomous cars driving. So that is happening at the moment. And smart cities, there was a lot of work there at the European level. I mean, the European Union is has a huge program of smart cities. There are a number of model cities across Europe. I'm not sure if one of them is in Germany. We try to, as we say, we try to in this program and try to position Bremen here where I'm from as a smart city, but that didn't go through. So yes, there are a number of initiatives here which try to, the smart city ones, they try to actually integrate all these different approaches to mobility, this multimodal mobility where you combine cars with bikes and public transport and so on. So that there was a lot of initiatives happening there.
All right, thank you. Well, smart mobility is a pretty much broad concept, and it might include autonomous driving vehicles or smart city systems. So it's a much or less a multidisciplinary kind of concept. Let me move over to Dr. Bhave from India. Could you give us some comments from your perspective?
Sure, Professor, thank you. So India has a program started by the government of India for Smart Cities Initiative in 2015. And that's a nationwide program which tries to connect cities together along with developing infrastructure for both mobility as well as telecommunication. I think they've started in Mumbai and Pune, which are two cities in India, also other places like Bangalore and the major cities. And that's ongoing right now. And that's something that will go on for the next 5 to 7 years, depending on the program duration. Other than that, I think in India, there are initiatives for the autonomous vehicle part from either companies or universities. So for example, I know that RI, which is the premier homologation company in India, it's the Automotive Research Association of India. It's a government body which promotes both AV as well as smart city testing. And they've got this program called Swayam Go, which means independent mobility for India. And they do a lot of test runs as well as race tracks and test tracks for autonomous vehicles. Apart from that, there are companies. So India is an agricultural country along with being a commercial country, right? So the agricultural sector specifically, a lot of farm equipment is being made smart. Companies like Mahindra, Tata, Escorts are making smart tractors, level 2 kind of tractors, geofence tractors. And then smart trucking, companies like Flux Auto are trying to do smart trucking. Siemens itself is doing work with the Siemens CT to do road conditioning monitoring in an autonomous way for Bangalore as part of the initiative with the Indian heavy industries. So there are ongoing initiatives both at the government level and at the private level to get mobility and autonomy into the Indian roads.
Thank you. India is a large country with a large populations, right? So you should definitely need high levels of technology for smart city or smart mobility as well as autonomous driving. Let me move over to let me move over to Mr. Trond Hovland. I think you are working on very closely on this area, smart intelligent transportation system. Am I right? So you should have a much things to say about your effort in your country. Please.
Thank you, Mr. Moderator. Yes, Norway, but we are a really small country compared to India. So I don't know, we have very few cities compared to almost every other countries. But at the moment, we have like 43 different smart city operations or projects around Norway. In 14 of these, we have trials with autonomous vehicles and also mass operations. In 6 of them, we have really a mature test and actually live driving of autonomous minibuses going on at the same time. So we have 2 in Oslo and one in Kongsberg, which is a small city, and we also have an on-demand shuttle for a small city in the area of Trondheim, where we also have an on-demand testing of autonomous shuttles. Not only roads, but they actually pick you up where you want to be picked up. And we have been doing over the years a lot of research in this area to find, like I told you about the barriers to being profitable in this area. But since we don't have a car industry in Norway, we do the research in other areas where we test the vehicles in bad weather conditions and in steep hills, and we measure the satisfaction of the customer, and we also try to run operations without the driver or without the host on board, so we can see how people react when there is actually nobody around and this vehicle is automatically operated, and how they interact with the vehicle to make it stop for the next passenger and stuff like that. There's really good insights that we gain from that. Further, we are doing mobility as a service project also in the same cities, where we have integrated bikes and scooters with the public transport sector and the public transport. We are doing actually a lot.
All right, thank you. Since we are pretty much limited in time, so we should be a little bit faster. Let me touch the major keyword of this conference of AI. So what do you think or how the AI technology be utilized for smart mobility system? Let us start from Professor Christopher Luth. Can you give us some idea how AI technology could be utilized for enhancing the level of a smart mobility generally?
Well, obviously there was a lot of AI functionality. As I said in the talk, for example, image recognition is these days something that is almost entirely done with deep learning. As I also said in the talk, you shouldn't use AI technologies, deep learning technologies for end-to-end control of an autonomous car. I think that's the main thing. There are various AI applications which can be useful in mobility. Not only image recognition, there's also, you could also, for example, you can do speech recognition, if that helps. Yes, as I said, you shouldn't use it for end-to-end control.
Okay. Let's move over to Dr. Bhave. Can you give us some hint how the AI could be utilized for smart mobility?
Sure. So, I mean, in terms of smart cars, Professor Luth has already talked about AI for autonomous driving. So on the smart city side, AI could be used for multiple things. So if you have vehicle to infrastructure communication or vehicle to vehicle communication, smart traffic lights, you could do regulatory flow of traffic. You could do a more efficient way of utilizing roadways and people. So AI could help regulate or give a global view of the whole city and where localities are more congested, less congested. So traffic would be more efficiently flowing. That's one example of AI for the smart city part.
Right, thank you. What about you, Mr. Hovland?
Well, there are several ways to do it also when it comes to mobility as a service. If you want to mix public transport with taxis and scooters and bikes, it is very important that you have the taxis and the bikes and the scooters in the right position or the right capacity at the right time. So to do optimization and prediction of where you want capacity and predict the need is something that we are trying to use AI for. And also we are using AI to optimize the routing network for the public transport, so that makes more sense compared to where you actually want to go, using the telecom indicators on where you're actually traveling. So we can actually use that backwards into the routing system. So we set up projects to use AI for mobility as a service operations as well.
Right, I agree. Okay, thank you. Next, I would like to ask the questions to individual. So let me start from Dr. Bhave. As for formal verifications, what is your distinguished approach in Siemens solution? Could you introduce about your distinguished feature of your solution from Siemens?
Sure. So I think in Siemens, so it's a big company. So I'll talk about DISW, the group I come from, along with Siemens Corporate Technology. So their formal verification is used a lot in getting the right requirements for your vehicle development program. So typically requirements are free-flowing natural language. There's been a major push by Siemens and by other companies where we're trying to see how much of these requirements can be formalized in some kind of temporal logic, for example, like linear temporal logic or signal temporal logic. So the specifications start out very clear, and then you can derive consistency checks, completeness checks from those requirements for the rest of the development cycle. That's one place where formal verification is used or will be used at Siemens. But what we also find is that formal verification for the bigger picture, which is for the vehicle, the autonomy of the vehicle, especially with deep learning components, it doesn't go a long way in verifying them because it quickly becomes a not scalable problem. So we typically combine simulation and verification together to scale the problem up. A lot of verification via simulation testing. And then for the corner cases or the dangerous scenarios, we do a formal verification by counterexample or falsification. So that's a sort of a different way we do it to be a practical approach to the problem.
Right. I personally, I do have experience in using the Siemens solution before. It's a very excellent simulators I have tested before. Thank you. Let me move over to Professor Luth. Could you tell me, will there be a way to enhance the safety or security of autonomous vehicle with the help of infrastructure or surrounding environment? Will that be possible?
Yes, certainly. There was a lot of work going on with these car to car and car to X, it's what's called. The car communicates with the environment. So you could have envision, for example, you could envision a car making contact with the traffic lights, so the traffic lights tell the car that I'm red now, you should stop. The car could communicate with other cars, and then there are ideas, for example, that if the car spots dangerous conditions on the road, for example, ice, then when traveling further, it warns the oncoming cars traveling in that direction that pay attention, there is ice on the road. Cars can similarly, they can broadcast this information about dangerous conditions and so on a network to all the other cars. So yes, there are a lot of ideas. There are a lot of technologies which are being tried out at the moment, being developed. Whether these are always sort of in addition to the onboard technologies, right? I mean, you shouldn't make the safety of the car depending on its capability to interact with the environment. The car should always be safe completely on its own. And then if it can interact with the environment, it can provide more safety, which in turn means it could provide more possibilities. For example, it could drive faster as long as it can communicate, safely communicate with the environment. But if it can't communicate with the environment anymore, then it should still be able to travel, maybe a bit slower. So the degraded functionality. So these are scenarios that are discussed at the moment.
That's right. I also believe that intelligent transportation system should also go with the autonomous driving technology development. Let me move over to Mr. Hovland. Due to the findings by KPMG, Norway is ranked third in the world when it comes to autonomy. How come? How would it be possible? Could you explain how did you achieve that kinds of fame?
Yeah, we were really surprised also when we saw that for the second year in a row, we were ranked number 3 on this KPMG maturity for autonomy when it comes to land transportation. And I read the reports, of course, and what it looks like is that they put weight on that we have a number of EVs, electrical vehicles in Norway. And there seems to be like a link between the next generation of cars being EVs, also being more adaptable to autonomy. So I think that is one of the weights that they have. We have about a little bit higher than 10% of our fleet is today electrical cars in Norway. So that's a substantial rate actually. And the other thing that they put weight on is that the government and the regulation is adapted also to do that, to do tests and trials, and also there is a willing to push it from the government side. The third one, I think, has to do with all the tests and trials that we have been doing with these small minibuses over many years. So we have a lot of experience doing pilots. Ever since 2015, there have been activities in Norway using small minibuses. First in confined areas, later in the normal traffic, and today actually in operation with numbered roads running completely autonomous in streets of Norway. So I think it's a combination of all of those. We had Singapore and the Netherlands in front of us, and they have similar weighting in their countries.
All right, thank you. I'd love to visit Norway someday to see your activities of deploying the autonomous vehicles in your country. Thank you. Let me ask a little bit more technical questions to the keynote speaker today, Christopher Luth, professor. What are the general ways of enhancing or guaranteeing the safety and security of a sub-symbolic AI technique, which means machine learning or deep learning? Could you please introduce one or two major approaches for that goal?
I think these approaches currently discussed, there are two main ways to attack this problem. One is to actually look at the network itself. So as I said, the network has all these weights, which are set during the training phase, and you can actually try to mathematically look into the behavior of the net. I mean, these networks don't really behave mysteriously; they behave very mathematically. So you can actually try to analyze their behavior. And there was work by people, for example, in Oxford, who have analyzed the way in which the methods, in which the networks are trained, and they have derived properties which they can guarantee. So they can, with specific training algorithms, they can guarantee that the network behaves in a certain way, even if the input data changes slightly. And they precisely define what it means to change slightly, right? So there are mathematical ways in which to analyze the behavior of the network and to give certain guarantees. But unfortunately, these guarantees aren't very strong. I mean, you can show that, for example, for a picture, very slight changes in the pixels don't really matter. The other way in which you can attack this problem is by more or less by simulation. So the idea is that you have a model of the environment, you use the model to train the network, you get a response of the network, and then you use that response to actually refine your model. And then you get a new model, you can do more training, you get refined behavior of the network, you get better answers. So you have this loop in which you, at the same time, you make the network better, and you make a more reliable model of the environment using simulation techniques. So these are the two approaches that I know.
Right, thank you. This subject is a very active research areas around the world, and personally, I also am very interested in this topic as well. So I work this area for some amount of time. Let me ask one final question to Mr. Hovland. What do you think are the major or important barriers to develop sustainable or safe or secure mobility sector?
That is a very good question, and we, as I said in the beginning, we have done a study on what are the barriers for actually deploying mobility as a service, next generation mobility in general, and also AI and autonomous driving. And to our surprise, we found that the business case actually was the biggest barrier to come over. I know that listening to Professor Lut, there are a lot of things to do in AI. There are a lot of things to do in a number of areas before we can have this next generation of mobility floating. But if we can't make the industry profitable, we won't succeed. They just don't want to help us. At least that is the finding that we have had in the Nordic countries. And one example is that the taxis that wants to kind of be part of the public transport to help out to make more seamless mobility, if they can't make money, they won't participate. They won't even share data. And this is the obstacle that we are facing, that actually we have to turn away from the technology and also look at the business side. That is unusual for us.
All right, thank you very much. AI and the mobility are two important keywords which should be developed, and it should be focused more around the world. So that's why we have to do more international collaborations between countries, as well as academia or industry or government aspect. So we all need further steps to go. I think time's up, and we have to finish this session. And I'd like to thank you for your attendance from Norway, as well as Germany, as well as from India. And thank you for your time, and thank you for your valuable insight and feedbacks and answers to my questions. Thank you very much again, and hope to see you again in another chance. Bye-bye.